Hi, this is Electronics. In this video I will build a TDA2013A bridged amplifier circuit on a breadboard. The TDA2013A is a very famous Class A/B amplifier IC because of the cheap price and easy to build circuit. As the datasheet shows, it can support high output current and it has a very low harmonic and crossover distortion. Let's start building the circuit on the breadboard. As you can see, the pins do not fit the holes of the breadboard, so I resolved this issue with jumper wires. I put a cable insulation on the pin of the IC and then I connect the jumper wire. This way is more easy to connect the pins to the breadboard. Also, the heatsink will have enough space and won't make a short circuit accidentally. Parts and tools required to do this connection: cable insulation pieces, precision forceps and a lot of patience. This is how it looks connected to the breadboard. I always leave a space between the pins so I can connect components more easily. Now you can see the pinout of the IC, and this is the circuit diagram which can be found in the datasheet. Both ICs are connected, they are easy to handle and the danger of short circuit is lower. I use a ±12V dual rate transformer for power supply, a 2A full bridge rectifier and two pieces of 4700 microfarad electrolytic capacitors. The ICs and the power supply is set up. Now the external components remain. I use masking tape to temporarily fix the ICs to the heatsink. I do not recommend doing this. It is better if the tabs of the ICs are not in direct connection with the heatsink. It's safer if you use TO220 heat insulation on both ICs. After this, I check the supply circuit if it is working properly by measuring the voltage on both rails. The first component is the 4.7 microfarad capacitor, which I put to the input. The negative pin is connected to the first pin of the IC and the signal will come from the positive pin. In the datasheet it shows 2.2 microfarad capacitor, but I used a 4.7 because the bandwidth will be larger in the low frequency region. Now I'm going to put a jumper wire from the ground rail to the other side of the breadboard. Also at the middle I put a small jumper wire, otherwise there will be no ground connection there. The next component is a 22K ohm resistor after the input capacitor. I use a 50K small trimmer potentiometer to control the volume of this circuit. The middle pin will be the output and it is connected to the input capacitor of the circuit. One of the pins goes to the ground and the other one will be connected to the input. The audio signal will come through this green wire. The next component is a pair of 10K ohm resistor which sets the gain of the amplifiers. It has to be connected between the pin 2 and pin 4 at both amplifier ICs. Another 22K ohm resistor is placed between the input pin of the second IC and ground rail. The blue wire is connected between the positive rail of the power supply and at the pin 5 for both amplifier ICs. The green wire is connected between the negative rail of the power supply and at the pin 3 also for both ICs. Now the power supply lines are connected. The next component is a 33 microfarad capacitor. I couldn't find a 22 microfarad capacitor as shown in the datasheet, so I used this one. It must be connected to the pin 2 for both amplifier ICs. A 22k ohm resistor must be placed between the two ICs. At first IC it is connected to the pin 4. At the second IC, instead of the pin 4, you must connect to the negative side of the 33 microfarad capacitor as shown on the circuit diagram. Two pieces of 1k resistors are placed between the negative pin of both 33 microfarad capacitor and the ground rail. I do not have 680 ohm resistor, so that is why I use 1k resistors. Here is the circuit diagram and the formula of the gain for both amplifier ICs. If I calculate the gain of my circuits, it will be 11, which is fairly low, because according to the datasheet the gain must be at least 24. When you are designing your own circuit, then this must be taken in consideration. The component I placed is a 330 nanofarad monolithic capacitor. I place one for each output. If you have polyester capacitors, then those are better, but still for me it worked fine with monolithic too. These capacitors will cut the high frequency oscillation. The datasheet recommends 220 nanofarad capacitor, with which the bandwidth will be larger at high frequencies and still no oscillation will occur. A pair of 1 ohm resistor is placed between the 330 nanofarad capacitors and the ground. If you do not have 1 ohm resistor, then you can try it without it. Just simply connect the capacitor to the ground and it should work. I placed 250 nanofarad ceramic decoupling capacitors to the power supply circuit. I place a wire to connect the power ground and another one to connect the other ceramic capacitor also to the ground. The last component is a 2200 microfarad capacitor to the output, so no DC will flow to the speaker. I speed up the video while I place the last connection wires. When you test the circuit, it is recommended to use a cheap speaker. The circuit is ready to be tested. Here are some troubleshoot tips. These components were chosen for the breadboard build, but if you want a good quality amplifier, then I recommend to use components listed in the datasheet. At the power supply, use a pair of 10 mF capacitors and a more powerful transformer. This way the ripple will be much lower, also the possibility of the distortion. If you notice hum in your circuit, try to separate the signal ground and the power ground. I think this is enough information to succeed in building. Good luck building your circuit. Leave a like if this video helped you to understand the circuit, and don't forget to subscribe for more videos like this.